Good day. In this tutorial, we are going to solve problems under annuities and capitalized costs. First problem, company Dito pays 8 pesos in dividends annually and estimates that they will pay the dividends indefinitely. How much are investors willing to pay for the dividend with a required rate of return of 5%? This is a perpetuity problem, and the formula is P is equals to A over I. P, present value, is equals to the A, cash flow, over the I, which is the interest rate or yield. By the way, a perpetuity is an annuity where the payment periods extend forever or in which the periodic payments continue indefinitely. In this problem, we have A as 8 pesos and I as 5%. Plugging in the values, we have P is equals to 8 pesos divided by 0.05. P therefore is equals to 160 pesos. Next problem, a young couple has decided to make advanced plans for financing their 3-year-old daughter's college education. Money can be deposited at 8% per year, compounded annually or yearly. What annual deposit on each birthday from the 4th to the 17th must be made to provide $7,000 on each birthday from the 18th to the 21st? Here we have a ordinary annuity problem. The strategy is to break into two cash flows. We have here in the right side the diagram and the given values as the withdrawals is equal to $7,000 and I, or the rate, is 8% per year compounded yearly. We will find A to the 4th to the 17th year. By the way, ordinary annuity is one where the equal payments are made at the end of each payment period starting from the first period. Now, our strategy is to break into two cash flows. So we will equate F to P. The formula for ordinary annuity for F is equals to A, F given A at I% in N interest period, while P is equals to A, P given A at I% in N interest period. F is the value or sum of money at some future time, while P is the value or sum of money at present. A is a series of periodic equal amounts of money. N is the number of interest periods, while I is the interest rate per interest period. We will now equate this notation of F to P. We substitute the value. So we are going to find for A, we have 1. This is for the left side. I is 0.08 raised to N, which is 14 interest period. Where do we get this? This is from the 4th to the 17th. So we count from 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th. So that is 14 periods. Minus 1 over 0.08, which is I, equals to, we have for the right side, A is the withdrawals at $7,000 multiplied by 1 minus 1 plus I, which is 0.08 raised to the negative N. We have negative N is from 18th to 21st. So we count 18th, 19th, 20th, 21. So we have 4 raised to the negative N is 4 over I, which is 0.08. Now we can solve for A. Therefore, A is equals to $957. Lastly, this is an ordinary annuity problem. Determine the value of each of the following annuity factors. We have 4 problems here. For the first, P given A at 4% at 8 interest periods. Number 2, F given A at 9.8% at 21 interest periods. Number 3, A given P 14.5% at 10 interest periods. And number 4, A given F at 6.3% at 15 interest periods. So we will use the formulas for ordinary annuity, and we are going to solve for the annuity factor. The annuity factor is the one encircled in red. So for letter A, we will just substitute the values. I is 0.04 in decimal numbers, raised to negative n, which is negative 8, over I, which is 0.04. Therefore, the annuity factor is 6.733 at 3 decimal places. Next, for number 2, we will just solve for this annuity factor. I is 9.8% or 0.098, raised to n, which is 21, minus 1 over I, which is 0.098. Solving this, we will get 62.477 in 3 decimal places. Next, for number 3, I for number 3 is 14.5% or 0.145 over 1 minus 1 plus 0.145 raised to the negative 10. We will get 0.195. Lastly, for number 4, I is 6.3% or 0.063 over 1 plus 0.063 raised to n, which is 15, minus 1. And for number 4, we will get 0.042 in 3 decimal places. Hope you have learned from this lesson, and I will see you on my next video. Stay safe and God bless you all.